All right, I'm going to be finding an energy level using this program. So this is just a one-dimensional time-independent Schrodinger solution using the Numerov solution as well as a differential equation solution. We're going to be focusing on the numerical one, or Numerov. So we can set the mass here as well as the energy and initial values for the two different solutions. So you can see that it goes from diverging up to down, back and forth multiple times before becoming this wavy behavior. Up here, it is unbounded. Down here, each time it goes, it switches from diverging up to down. It switches right around an energy level. So we're going to pick this one. Now it's easier to see which one it is because a line, easier to see without normalization. You can see that a line will appear here. So right above, we can set a maximum. This changes the upper bound of the slider. And right below, we can set a minimum. And we can keep doing this until we have the precision in order to get really, really close to the energy level. We're going to do this several times. That might be enough. Still pretty hard to get close. But you can see the wave function kind of starting to appear here. All right, so now it's approaching zero at both ends. We can turn on probability, the wave function squared. We can check the normalization by turning it off, and then this shows the area under the probability curve. Uh, sorry, the square root of the area under the probability curve. So divide the wave function at every point by this value. And we can check the other solution, which has a very similar curve. However, it still diverges. So they don't agree perfectly on the energy value. And also interesting is that changing the initial values has very little, if any, effect on the form of the wave at this point. However, it does change the normalization, sometimes by a handful of orders of magnitude. At the values that are initially set, usually these two are fairly close in normalization. We can reset the energy here, and we can look for a different one. All right.